Okay, so this video is going to be on trig identities, probably the basic ones we'll call them. And there are some you certainly know already, like you know that tangent is sine over cosine, or y over x. You know that if you take sine and reciprocal it, you get cosecant. If you take cosine and flip it into the bottom, right, you'll get secant. And you can kind of understand that you probably kind of knew that this was, if this is y over x, this is x over y, right? So all of these things are kind of making sense to you. Obviously, if 1 over sine is cosecant, then 1 over cosecant is sine. So the green ones were supposed to be the ones that you kind of already knew. And now in sort of a way, we're adding to this. So what we want to be able to do is basically just understand and memorize a lot of these things about trig that are always true. That will help us simplify and later solve equations. So just working with trig a lot easier by just understanding it. So it's almost like we're doing algebra with trig quite soon. We first numerically learned the values of the trig, and we work with triangles. Then we extended that, then we graphed it, and now we're sort of doing algebra with it. That's the best way I could explain it. So this is a pretty straightforward starter. If secant is negative, if secant is negative root 30 over 3, what's cosine? Well, that's 1 over secant. So we just need to flip it. So we're just going to need to have this. And then, of course, we'll need to rationalize that. There's like a dead spot on my touch screen or something, and it's not fun for me. So that will give us negative root 3 30 over 30. And if you simplify that, that'll just be negative root 30 over 10. Okay. That is pretty much your most basic, like what we'll start with. Then we'll get into some more involved ones, I guess you could say. I'm just going to try to test out where that spot is. Okay, perfect. So since that's there, that means I can do this probably. And I'll still not have problems with it. Sorry that I'm doing that. Okay, perfect. So what we know is that if tangent is this and cosine is this, find sine. So let's remember that tangent of x is sine of x over cosine of x. And then let's fill in what we know. Well, we know this, right? Let's use red. So we know root 2 over 4 would equal, we don't know sine of x, so we'll leave that. That's what we're trying to find, and we do know cosine of x, right here. Negative 2 root 2 over 3. Now this is where you got to stay sharp with your algebra, because there are going to be some things that are a little uncomfortable here perhaps. So for example, to cancel out this negative 2 root 2 over 3, we'll multiply by it, which means we have to multiply by negative 2 root 2 over 3 here. So that means that sine of x will end up coming out to negative, well, this is the square root of 4, so this is going to be 2 times 2. It's going to be 4. And actually, because of that, because this all equals 4, we can cancel with that. So it should come out to negative 1/3. Okay, that is a start. Let's continue. Okay, so it's going to get more difficult as time goes on. I'm glad it started off nice, but it does get kind of tricky here. Okay, there's where our issue is. Okay, perfect. So we have cosecant, we have cotangent, we need to find secant. So let's think about what we know. Well, we pretty quickly could say that cotangent, and I'm just going to say x, would equal cosine over sine. It's one you're going to want to memorize. I don't have much of this, but I do have cotangent, so I'll put negative 2 root 10 over 3 is going to equal, and I have cosecant, which is the reciprocal, right, of sine. So if I wanted to figure out sine, it would just be 3 over 7. It'd be the flipped cosecant. And cosine we're not going to know. That's what we're trying to find, right? If we find cosine, then we can find secant, because they're super related. We'll just flip it. So I'll multiply by 3/7. Sorry about the colors. I'll multiply by 3/7 on both sides. I'll cancel these 3's. And that means that cosine of x is negative 2 root 10 over 7. And that means that secant of x, if we flip it, is negative 7 over 2 root 10. But we don't want a root 10. So we now have negative 7 root 10 over 20. And that should be good. Okay, next we talk about the Pythagorean identities, and we may just get through this section and not a lot more. What I want to talk about is the most important one. I typically write this one as sine squared plus cosine squared equals 1. I might have mentioned it to you a couple times, but I don't think we've done a lot with it. So the idea is that sine squared plus cosine squared is equal to 1. And if we want to just kind of prove that, so just for a second, because I wouldn't be doing my job if I didn't show you why. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. We're trying to figure out if that equals 1. We also should have squared these, of course, right? So that means we have opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared equals 1. Which means we have opposite squared plus adjacent squared by common denominator over hypotenuse squared equaling 1. Now, let me draw a triangle. This is hypotenuse. This is opposite. This is adjacent, right? What can you say about this triangle? Pythagorean theorem says so if a squared plus b squared equals c squared, then this must equal h squared, and h squared over h squared, right, is 1. So that's where that identity comes from. Now, the second part, which is probably more important than that, I mean, I wish that that part would stick with you and that you would love it, but this part I think is more important. You can memorize all of these, but I don't. What I do is I take this and I divide by either sine squared or by cosine squared each time to get my next identity. So I take cosine squared, right? Cosine squared plus, this should have a theta on it, sorry, plus sine squared theta equals 1, and I divide it by, in this case, let's divide by cosine squared theta. Cosine squared theta. Cosine squared theta. That gives me 1 plus sine over cosine is tangent. Sine squared over cosine squared is tangent squared. And 1 over cosine is secant, so this is secant squared. So now you'll see that I've found this identity. Okay, and the same thing would work if instead of the green, instead of dividing by cosine, which we did in green, we divided by sine. We'd get that third identity. So I don't memorize all 3, I just know the red one, and I derive the others, and I will do that many times for you throughout the process, but if you want to memorize all 3, that's fine. Okay, so we have tangent, cosine, and sine, so how are they related? I mean, I think the first thing I would do, I don't see why I can't just, no, I can't really do it, can I? I would put tangent, see I don't have two things. I have two unknowns. That's what's causing an issue here. So what I'm going to do is, instead of trying to make tangent sine over cosine, right? So it's kind of like factoring. You need to figure out what's useful. I'm going to say sine squared plus cosine squared equals 1. Oops, sorry, this should be x's. I'm then going to put in what sine is right here. So that's negative a third squared, sine squared. It's all going to come out to 1. We're trying to find cosine squared. That's what we're looking for right now. So let's try to figure that out. So what we're going to end up with is a 9th over here. And if we subtract a 9th on both sides, we'll have cosine squared equals 8/9. And that means if we square root both sides, we'll have cosine of x equals plus or minus the square root of 8/9, which is 8 is going to be 2 root 2. That's one I just memorized over time. And square root of 9 is going to be 3. It's plus or minus that. So cosine squared, or cosine of x, is going to equal plus or minus that. Here's my question. If cotangent is negative, right? Sorry about that. If cotangent of theta is negative, and that's cosine over, that should be a theta, over sine, then that means that, well, we saw that sine was negative, and this is negative, right? That means that cosine must be positive. So see the sine thing here? Sorry about all the same colors. We saw that sine was negative by this negative sign. Gosh, that's horrible. By this negative sign up here, though. Okay? We saw that cotangent was negative by this, right? So that's why this is negative and this is negative. These are both negative. That means that cosine must be positive. So I'm going to take the positive version of this instead of the negative. So I'm tossing this negative and keeping that. So we've figured out half of our problem, and now we need to figure out tangent. And since we have sine and cosine, we can just figure out tangent by dividing those. So if we have sine, which is negative 1/3, and we have cosine, which is 2 root 2 over 3, we could say that that's equal to tangent of theta, because sine over cosine is tangent of theta, and I'm going to go over this way. And that would be, I guess, negative a third times 3 over 2 root 2. Cancel, cancel. I'm kind of going all over the place, sorry. And that's negative 1 over 2 root 2. And we'll rationalize for good measure. And when we finally rationalize this, we get negative root 2 over 4. 2 times 2. So negative root 2 over 4 should be tangent of theta. I'm sorry that I keep using x and theta, and sometimes it has a beta, so my apologies on that. Okay, we are in good shape right now. Everything's looking good. We're going to continue. And this will probably be the last one, because it doesn't seem like we're going to get through a ton more after this. Let's see what we can do here. Okay, cool. So, find tangent and sine if secant is this and sine is that. So this one I kind of do like, because see, I don't know if I could have done this with the other one. Could I have? I probably could have. Let's see. Sorry, I haven't told you what I'm talking about. Yeah, I think I could have done this. So what I'm going to try to do is I'm going to try to figure out the quadrant. So the quadrant thing can still be kind of like useful. See how sine is positive, so that means we are either here or here. We're in all our students. And the reason I think we're in all is because secant is positive, which means cosine is positive. So we're in quadrant 1. So this is something that could be useful to you. So we know that tangent is going to be positive. We know that sine is going to be positive. They told us that. So they gave us secant. I have tangent, I have sine. I'd really like cosine, not secant. So cosine of x is 5 over 6. Just flip it. It seems like we have a lot of information about, could we draw a triangle? Maybe we could. There's probably multiple ways to go about this, but I want to go about this the way that they are intending for us to go about it. And the way that they want us to do this is they want us to realize that sine squared of x plus cosine squared of x. Is it okay if I just put what cosine squared of x, what cosine of x is, and then square it? Sine squared of x plus cosine squared of x equals 1. So that means we get 25 over 36. That was supposed to be an equals. We're going to subtract that from both sides. So we'll subtract that from both sides. And we'll wind up with the following. We'll wind up with sine squared of x equals, we're taking 25 from 36, so 36 over 36 minus 25, so 11 over 36. Square root both sides. They told us sine was going to be positive, so technically this is sine of x, when I square root, is going to equal plus or minus the square root of 11 over 6. We have to decide what version we want. They told us sine was positive, so sine of x is going to equal square root of 11 over 6, positive. Now I guess if we have sine and we have cosine, we can just divide them to get tangent. 5 over 6 and 11 over 6. Sorry, root 11. Root 11 over 6 over 5 over 6. This should be tangent. That's sine over cosine. And I guess that's going to be so tangent, which is sine over cosine. So again, sorry about a little bit of sloppiness here. Tangent sine over cosine for those reasons. So now we have root 11 over 6. So tangent of x is root, oh god, tangent of x equals root 11 over 6. And that is a good start. So if you're dealing with the packet, you have this handout in front of you, and you have multiple pages, you're probably going to flip from, pages 1 and 2, from this page, or rather from this page, you're going to flip 2 pages forward and try to practice these types of problems. So hopefully that was somewhat clear and helpful. I will see you in the next video.